Okay, so with that problem at hand, you have the following linear programming model. So as always, the same with solving it using graphical, you have to also create first the linear programming model. So in this case, we'll let x1, x2, and x3 be the number of units produced of products A, B, and C respectively. So don't forget to put let.
X1 will be for the number of products for type A, and then X2 for the number of products for type B, and X3 will be the number of products for type C.
So as mentioned, when we talk about simplex, it is applicable if the number of variables are already greater than 2. If the variables are only 2, then we can use graphical because we can have x and y axis. But for more than 2 variables, simplex is the most ideal. Although simplex can still be used for variables with only a problem with only 2 variables. Okay, so as seen in your courseware, you have the table guide for your constraints and objective function. So, right. So, of course, the very first part, and don't forget your z as, here, let's just place here, z as your profit in dollars. Okay. So, based on the table, your objective function, so objective function always comes either in maximization of profit or minimization of cost. So in this case, you're asked to get the maximum profit where for every $5 of type A, $10 of type B, and $8 of type C. Okay, and then your subjected to the constraints. So we have for fabrication constraint, that's 3 hours for x1, 5 hours for x2. Was it hours? Let's confirm. Yeah, hours. And then 5 hours for x2 and 2 for x3. Since it talks about availability in hours, so it's less than or equal to 60. Same goes to finishing. So for finishing, that's 4x1 plus 4x2 plus 4x3. So if everything is in hours, dapat the right hand side also is in hours. So 72. And for packaging, that's 2 for x1, 4 for x2, and 5 for x3. So the good thing with having a table before creating a linear programming model is that you can just copy paste automatically in creating the probability. And of course, in creating your tableaus or tables. Okay, and don't forget your non-negativity constraints. So that all your answers should be all positive, no negative answers. All right, so once your LP model is done, you have to translate that. Okay, let's just leave the LP model. We have to translate that into a function that is equal, no? So we translate this into equalities. So how do we translate that into equalities? As mentioned, if the symbol is less than or equal to, we will add a slack variable so that whatever is missing here it is just added because it's less than or equal to, because as mentioned, when we say less than or equal to, posible na naikuwang posible na naisubra from this equation. Okay? But if it's greater than or equal to, we subtract surplus because we should not be more than there is a tendency that the values here is greater than your target. Because if it's greater than 60, possible it could be 63. So therefore 3 is the surplus, so on and so forth. So that's the purpose of changing that into equalities, because we are going to use these artificial variables. We are going to use these artificial variables in creating the tableau. Okay, so therefore this becomes 3x1 plus 5x2 plus 2x3 plus, we translate this to 3x1 plus 5x2 plus 2x3, and then we add a slack variable equals 60. So we translate already the inequality to equality. Okay? And then S1 is the slack variable for the fabrication constraint. And then for x1
plus 4x2 plus 4x3 plus s2, meaning another slack variable for the finishing constraint. So equals 72, and then 2x1 plus 4x2 plus 5x3 plus s3, meaning another slack variable for the packaging constraint, equals 100. So your non-negativity now includes your slack variables. And don't
forget that you are going to add here your slack variables because they are present in your constraints. But the profit is just 0 because, of course, as mentioned, they are only artificial variables. So 0s1, 0s2, and 0s3. Okay, so that is now your linear programming. That is your linear programming model for Simplex. Now, you are going to use that in your initial tableau so that you can still see. Okay. So we create now our initial tableau. So as you've seen in your courseware, the initial tableau consists of the values or the coefficients from the linear programming model. So we start with, since in creating an initial tableau, your initial solutions are your artificial variables. So your initial solutions for the meantime will be your artificial variables. So that's why S1, S2, and S3 are your initial solutions.
And then, so this is a simpler way as discussed in the courseware. And then you write all your variables here. X2, X3, S1, and then S2, and then S3. Okay? Then don't forget your right hand side. So your right hand side values as well. So you just write this one. Okay, please follow this one. So that's 3, 5, 2, 1, and then there are no S2 and S3, and then that's 60. 4, 4, 4, and then 1 for S2, 72, and then 2, 4, 5, no S1 and S2, only S3, and then 100. And don't forget your profit. So your profit row, or your zero, we call that as your Z row. So for your zero, that's, okay, by the way,
when we create objective function, there should be no variables in the equality sign. That is why we move everything to the other side, no? So your new objective function should be z minus 5x1 minus 10x2 minus 8x3 minus, of course there's no minus 0, diba? 0s2 and 0s3. So that is why your
z here is negative 5, negative 10, negative 8, and of course 0, 0, 0.
The rule in Simplex is that you will stop already if the 0 are all positive values. Okay, so in this case, since we have still 3 values or variables with negative 0, obviously that is not the final answer. The artificial variables are not your final answers. So what we're gonna do first is find our pivot column. So our pivot column should be the one with the most most negative value. So in this case, from -5, -10, -8, -10 is your most negative. So since that is your most negative, this column here is our pivot column. So we call that as our pivot column. Okay, so for your pivot row, you will have to divide. So we create a ratio. We call that as minimum ratio. We find the most minimum ratio by dividing the right hand side to the coefficient of that pivot column. So 60 divided by 5, that's 12. Then 72 divided by 4, that's 18. And 100 divided by 4, so 72 divided by 4, 100 divided by 4, okay, that's 25. And to choose our pivot row, it should be the row with the most minimum ratio. So that means it's 12. So that is your pivot row. Now, getting already your pivot row, this is your pivot row, and column, and this is your pivot row. That means 5 is your pivot element. So 5 then is your pivot element.
Okay, so next step is create the next tableau. So to create the next tableau, we call it as our second tableau. So for our second tableau, still redraw the table 1, 2, 3, 4, 5, 6, 7. 5, 6, 7.
This time, since x2 is our incoming variable, s1 is our leaving variable, meaning to say they will have to exchange. So still this is x1, but this is now s1. So s1 left in your initial solutions and x2 comes in. And then x3 remains, the other remains here. And then your right hand side. And then this becomes x2, s2, and s3, and of course don't forget your 0.
So to create the new tableau, we have what we call the new pivot row. So the new pivot row, since this is your pivot row from the previous table, to create the pivot row, I'm going to write here the formula. So new pivot row is equal to your current value in the pivot row divided by your pivot element. Okay, so meaning to say that's 3 over 5, that's 5 over 5, okay, so meaning 3 divided by 5, so that's 3/5. So I suggest you use fractions. 5 divided by 5, that's 1, 2 divided by 5, that's 2/5, 1/5, of course that's 0, 0, and 60 divided by 5 is 12. So the value here appears, no? Okay, now there is also what we call the new rows. So the other two rows, we should have to fill them in as well. So for the new rows, what you're going to do is your current row value minus its pivot column coefficient times the new pivot row. So make sure your new pivot row values are correct. So in that case, for example, let's use this one. So for the 4, so for this area, dimension, the current row value, so 4, meaning, I'm going to show here, 4 minus its pivot column coefficient. Your pivot column coefficient is 4. So minus 4, okay, times your new pivot row. Your new pivot row value in that line is 3/5 times 3/5. Okay, so therefore the value here is 8/5. Because that is like 4 minus 12 over 5, right? And then 5, that's 20 minus 12, so that's 8/5. Okay, so you do the same for all. Here, your clue here is, so 4 minus itself times the new pivot row, which is 1. So 4 minus 4 is 0. So same here, 4 minus 4 times 2/5, which is 12 fives. And then we have 0 minus 4 times 1/5. Yes, so you reiterate the process. Okay, so that's negative 4/5, and then we have 1, and then 0. And then same here, no? So I'm going to show you this area for this. So 72, okay, minus its pivot column coefficient of 4 times the new row, which is 12. So 72 minus 10 times the new row 3 fifths, that's negative fifth minus negative 10 times 3 fifths. So that is negative 5 plus 30 over 5. 30 over 5 is 6, right? So negative 5 plus 6, positive 1. So this is positive 1. And then we have 0. And then
Negative 4. So there's still a negative value. So we should not stop yet. Okay. Next, move to the third tableau. So for the third tableau, we repeat the same process. Okay? So this time, we are to choose our new pivot column and pivot row. So since yan naman lang ang negative, so siya gidato ang pivot column. Okay? And then here, we have to divide it to 2 fifths, 12 fives, and 17 fives. So that's
12 divided by 2 fifths, that's 30. 24 divided by 12 over 5, that's 10. And 52 divided by 17 over 5, that's 15.294. So we need to say we will choose 10 since 10 is the most minimum ratio. S2 becomes your new pivot row. Now for your pivot row in the second tableau, your pivot element is 12 over 5. Okay. So doing the same process for the third tableau. So we have now a third tableau. So for your third tableau, x3 goes in and becomes a solution and s2 leaves. Okay, so that's still x2. This is now x3, s3, and then z. And then we have x1, s1, x1, s1, and then s2, another s1, s2, and s3. So, and of course don't forget your right hand side. So this is now your new row, so x3, you're going to create a new row. So new pivot row. New pivot row is current pivot row over your pivot element. So 8 over 5 divided by 12 fifths, that is 2 thirds. Okay, so going back, so to create the new pivot rows, again, we already determined our pivot rows and pivot column from second tableau. So in this case, we are to change the second row. No? So how do we create the new pivot row? Again, current pivot row divided by your pivot element. So that's 8 fifths divided by 12 fifths, so that's 8 over 12 or 2 thirds. Okay, 0 divided by 12 over 5th, of course that's 0. And then 12 fifths over 12 fifths is just 1. And then negative 4 fifths over 12 over 5. So your fifths are cancelled, so that's negative 4 over 12 or negative 1 third. Okay, 1 divided by 12 over 5, so that's the opposite, 5 over 12. And then 0 over, that's 0. 34 over 12 fifths, which is actually your chosen minimum ratio, no? A while ago. So another one, create yapunta for the new row. So for the new rows, your current row value, that's 3 fifths minus its pivot column coefficient, 2 fifths, times the new pivot row of 2 thirds. Okay? So that is 1 third. So double check, 3 fifths, okay, minus its pivot column coefficient, times your new row, which is 2 thirds. So that is 3 fifths minus 4 over 15, am I correct? So common, 3 times 3, 9, minus 4, that's 5 over 15 or 1 third. Okay? So that, just to double check. And then that is 1 times, minus 0, so obviously minus 0, so that's just 1. And then your clue is the pivot column will only have the one value for its pivot element, the rest will be zeros. Okay, so that's your clue. And then for S1 row, so we have 1 fifth minus its pivot column coefficient 2 fifths times your new row, which is negative 1 third. So your answer is 1 third. So same goes for S2, negative 1 sixth, and then 0. Okay, so for your right hand side, that's 30. Oh no, sorry, 12, right? 12. So that's 12 minus its pivot column coefficient of 2 fifths times the new pivot row, which is 10. So 12 minus 20 over 5. How much is that? So 12 minus 20 over 5. So that's 8. Okay? And then, same goes here for S3. So I'm just going to write everything out. So that's 8 thirds, 0, 0, 1 third, negative 17, 12, and then 1, and then that's 18. Okay? And then for the last one, 0. So hopefully the values are already positive so that we will already end. No? So for Z, that's 26 over 3. And then, 11 over 3. 11 over 3. And then X2 is 0, 0. And then that's 2 thirds, 5 thirds, and 0. So therefore, all values in the 0 is positive. That means your final answers are X2 is 8. X3 is 10. And then you have a slack variable of 18 for the packaging department. So your final answers are X2 is 8, x3 is 10. Therefore, x1 is 0, giving you a profit of, so z is equal to 0 times 5 plus x2 is 10, right? So $10 times 8 plus 10 times $8. Is it correct? Yeah. So therefore, your answer is 80 plus 80 is $160.
So these are now your answers. Any questions? Please comment.